Okay, welcome to this video where we're going to try and get x alone because we don't like our x's and we want them to be alone. Please don't write. I don't need. I'm totally over my x. Just saying. No, I'm just kidding. No, I'm not kidding. Anyway, let me just get to the math. Okay, so this math is we want x alone. Now I can guess numbers, but that's not going to work. We know, so we have to kind of get x out of this relationship it's in. So it's being added, but it's also being multiplied. But x is not being multiplied on its own. It's being, it's 2 added and then multiplied. So in order to get this thing alone, we have to kind of distribute and expand these brackets. So this 2 is multiplied by the x, and that 2 is multiplied by that 2. So we have to kind of do that first. I can't just minus a 2 because this is not really a 2. This is a 2 being multiplied by a 2. So I can't just say, oh, minus 2 on both sides, because this 2 in here is actually in a relationship itself with this 2 as well. So kind of complicated. So I have to or uncomplicate this. So 2 times x is 2x, and then 2 times 2 is 4, and that is equal to 3. And the next step is to kind of undo this plus 4 part. So I can do that by minusing 4 on both sides. So here I'm left with 2x is because minus 4 plus 4 is 0. And then here 3 minus 4 is negative 1. And now, it doesn't look nice, but we have this x being multiplied by 2. So I have to divide it because that's the opposite. Whatever I'm doing, I should just do the inverse, and therefore I'm going to divide that side by 2 as well. And the 2's would cancel, and I'd have x is negative 1 over 2. So that's basically my answer. Let's take a look at another example here, a little bit different. Till now we've done only having one x. But let's say there were multiple x's. Oh my goodness, hopefully you don't have multiple x's in your life. But let's just take a look. So the rule usually here is we want to get all the x's on one side, or all the common, like the like terms on one side, all the x's, and all the numbers on the other side. And in order to do this, I actually have to get this x on that side because there's more x's here, right? So I can subtract an x on this side, but then I have to subtract an x on the other side as well. So what I'll be left with is, let's just write that nicely, 2x plus 3x minus, I'm going to write 1x just for the explanation coming up next. And then that's equal to 4 because plus x minus x is 0. Now these are like terms, they're all x's. So very important, there's not an x squared in here. If there was an x squared in here, there would be a totally different method that we would follow, and we're not going to look at that right now. Maybe at the end of the series we might look at that, but these aren't the same. Well, this and this won't be the same. It's like meters and square meters. Adding them together is just not possible. But in this case, we're lucky. We got only x's, and I have 2 plus 3, which is 5, minus 1, which is 4x, is equal to x. And in order to get this x alone now, we just, because it's multiplied by 4, I divide by 4. And we get x is equal to 1.